Hi, high schoolers. Miss Knutson here again. Today in geometry, we are starting to talk about triangles, and I think you will find a lot of what we looked at with angles last week will be helpful when we talk about triangles today. And we will be describing triangles based on their attributes or characteristics that are true about different kinds of triangles. One other thing, I would like you to have paper and pencil to take some notes as we go through the slides today. There's a few different times where I want you to check some math or write down what kind of triangle do you think this is. So it would be helpful to have something to take notes on. If you need to pause now, go ahead and get that. So we'll look at these different words related to triangles today. Acute triangle, right triangle, obtuse triangle, and those words should sound very familiar. Equilateral triangle, maybe see the part of the word equal in equilateral. Isosceles triangle and scalene triangle. So to begin, a triangle is a two-dimensional flat shape with three sides. So all of these are different kinds of triangles, but they are all triangles. They have three sides. So I want to figure this problem out. The three interior angles add up to blank degrees. One thing about triangles that is always true no matter what kind of triangle is the interior angles always add up to the same number. So in this triangle, we have angle A measures 47 degrees, angle B measures 96 degrees, just over that right angle, and angle C measures 37 degrees. So go ahead and add all of those up and see what we get for a total. And if you're almost done, but I'm going to interrupt you, you can pause and finish. So hopefully we found that these angles all add up to 180 degrees. That is true. And that is going to be true no matter what kind of triangle we're talking about. The angles on the inside of the triangle always equal 180 degrees when you add them all together. All right, so an acute triangle is a triangle with all acute angles, or angles less than 90 degrees. So if we look at this triangle here, let's look at each angle. Angle P, 80 degrees. Angle R, 70 degrees. Angle Q, 30 degrees. All of the angles are less than 90 degrees. And if we would add these up, 70 and 30 is 100 plus 80, 180. That's still true. So let's look at this example. Go ahead and do this math, adding up the measure of each of these three angles. 56 plus 50 plus 74. What do you get? Hopefully you found we get a sum of 180. So all three angles equal 180. And again, this is an acute triangle because all of the angle measurements are less than 90. Okay, next we have a right triangle, and that's a triangle with one right angle, or measuring exactly 90 degrees. And we can only have one right angle. The other angles do need to be less than 90 degrees. And if you think about it, if we had a second right angle, we would already be at 90 plus 90 is 180 degrees. And we need a third angle, that's part of a triangle, so that wouldn't work. Obtuse triangle is a triangle with one obtuse angle. And kind of like a right triangle, it can only be one obtuse angle. So if you look here, angle B measures 110. That's the obtuse angle, which means then the other angles, A and C, need to be acute angles, and they are. And then again, we have a total of 180 degrees. So let's look at that. That was the one I just said, I think so. Our total, when we add up all the angles, 180. Okay, now we're looking at triangles based, not so much, we're not thinking about the angles inside, we're more looking at the sides on the outside. Equilateral triangle is a triangle with all sides the same length, or all sides equal length. An isosceles triangle is a triangle with at least two congruent sides, and congruent means sides the same length, so same length. So in this triangle here, we're showing that this side and this side are the same length with these little notches. The bottom, the base, would have a different length. So isosceles is a triangle with at least two congruent sides. And finally, a scalene triangle is a triangle whose sides are all different lengths. No side measures the same as another side. These are just some notes reviewing all the triangles we just talked about. I would suggest pausing this and writing these down so you have them. I'm going to move on for now, but I would pause and take notes on these. Okay, let's look at a few real-world examples. This is a yield sign. And I want you to think about how could we fill in this sentence I have started below. This is a blank triangle because, like, why? How do we know? And I will say more than one answer might work for what kind of triangle this is. Maybe just think of one. And you can say it out loud, or you can pause the video and write this down, because in a minute I'll show the answers. What kind of triangle is this? How do you know? So you could have said, this is an acute triangle because the angles measure less than 90 degrees, all of the angles. Or you could have said this is an equilateral triangle because all sides are equal length or the same length. Okay, let's look at the next one. This is a little birdhouse. This is a blank triangle because, and again, you can pause me so you can write this down or say out loud what you think it is. And it is good practice to actually say or write it before you see the answer. So you could have said, and you didn't have to do two, just I'm looking for one. This is a right triangle because of the angle, one of the angles measures 90 degrees in the corner here. Or I think it's kind of close, but this is a scalene triangle because none of the sides are the same length, or no sides are equal length. If you had said isosceles because you thought this side and the base here are equal length, I think you could argue that without us actually measuring this birdhouse. Okay, let's do one more. And remember to pause and either say or write the answer yourself before seeing the answer. So in this one, I'm looking at this gray top part of the house. What kind of triangle and how do you know, or why do you say that? So this would be an obtuse triangle because this top angle here measures greater than 90 degrees. It's also an isosceles triangle because it has two equal sides. This one, this top line, and this one would be equal. All right, so feel free to look back at any parts of this that weren't clear, or watch the whole thing again if that would help you, because this is it for our work today.